Right, friends. Hello, welcome to PKSL classes. This is a very important video. It's a new concept which was not given in the study material, but it was given in the May 2021 RTP. Now it's relevant for July exams. And many students have messaged me personally asking that they're not able to understand what it is. So they wanted me to make a video on that, and this is for you people. So I hope this video really helps you to understand this particular concept. Okay, right. So without wasting any further time, let's move on. Right, so this is the fourth question when it comes to May 2021 RTP. Okay, so this is based on the concept cellular manufacturing. In fact, those who have listened to my classes, you guys know that we have understood the concept of cellular manufacturing in the best way possible. In fact, those who have attended my face-to-face classes, you have seen that we have done an experiment based on the toasted breads and the sandwich, the jammed bread and all that in the live class. And those who have listened to my online classes, I would have just explained you that in the air, because unfortunately we cannot do the experiment when it is online classes, right? So unless it is physical. Okay, anyway, so you guys are already aware of it, but still we'll be seeing some different angles with respect to cellular manufacturing, because altogether a new concept has been touched upon here, that is rank based clustering algorithm. So how you will cluster the missions. Anyway, we'll see that later. First, let's read the question and then we'll move on. It has been resolved that cellular manufacturing shall be adopted in order to improve productivity. Sorry for that, guys, power issue. Anyways, so cellular manufacturing should be adopted in order to improve productivity. Okay, so we know that it's part and parcel of lean system. Ultimately, your purpose of lean system is to improve the productivity, right? In the recent board meeting, Raptor Bearing and Shaft Limited, in favor of the resolution, Mr. Nayak, the executive director, who is responsible for production and operation function, gave a briefing over different layouts of cells. The managing director, Mr. Sayal, believes that each possible cell formation and layout need to be studied in advance by the cross-functional team. Cross-functional team is another keyword. I've told you guys in many of my classes that this is a very important keyword, right? Chalo, Chief HR Officer Mr. Mishra shown his concern over the utility of cellular manufacturing to enhance productivity. Obviously, he's right. In response to him, Mr. Nayak mentioned, although scientific management is quite an old theory of management produced by Frederick Winslow Taylor, which analyzes and synthesizes workflows with the objective of improving economic efficiency, especially labor productivity, but still has relevance, although it is old. This relevance multifolds when time and motion studies are considered in nexus with cellular manufacturing. In fact, cellular manufacturing is nothing but time and motion study. Mr. Nayak constituted a cross-functional team with the term of reference stated in said board resolution. You are also part of the team as a representative of the management accounting division. The team started with a study of different possible layouts and machine cell designs. While analyzing the production flow, it is observed that 5 different parts or components, that is P101, 104, 105, 107 and 108, are complexly involved in processing 5 different machines, M2, M7, M13, M13A and M15. Part machine incident matrix for production flow analysis for the set product is given below. So you've got all this P101, 104, 105, 107, 108 and all these things. Here 1 actually represents, it's a denotion. Like for example, part 101 requires machine 2 and machine 13. Part 104 requires machine 7 and machine 13A. Part 105 requires only machine 13A. Part 107 requires machine 13 and machine 15. Part 108 requires only machine 7. So that's the logic. Here anyway the interpretation is also given. Part 101 requires processing at machine 2 and machine 13. Whereas part 104 requires processing at machine 7 and machine 13A. So that interpretation is also given. So no worries. So what is that you are required to do? Discuss the concern expressed by Mr. Mishra over the utility of cellular manufacturing. Okay. Explain the utility of at least 3 machine cell designs which can be used. Okay, 3 different types of machine cell designs. And we need to explain the utility of the same. Find logical part families and machine groups based on part machine incident metrics to showcase machine part grouping using rank order clustering algorithm. Okay, so that is what we're gonna do. So what you guys first do is that I'll give you 2 minutes of time. If not, I'll give you 3 minutes. Read the question. Once you're done with your reading, we will start. Read the question, guys. Right, guys, I hope you're done with your question. Chalo. Let's start answering this. First one, discuss the concern expressed by Mr. Mishra over the utility of cellular manufacturing. Okay, he feels that. What does Mr. Mishra feel? Huh. Yeah. So he says that utility of cellular manufacturing to enhance what? Productivity. That's what we're gonna discuss, right? Chalo. Anyways, right now, see you guys. So we'll start with cellular manufacturing over here, right? What do you mean by cellular manufacturing? We are already aware of it. It is a lean way to enhance productivity, which means because it comes under lean system and innovation, we have already studied it. So obviously, it's a lean way to improve your productivity. It's a time and motion study that also we are aware of it. We have seen it many a time so far in many problems. There are two more important wordings. For example, cellular manufacturing is nothing but application of group technology in manufacturing. Why? Because you are grouping your machines, right? And you are converting that into manufacturing cells. Now, manufacturing cells is nothing but group of machines which are going to produce family of parts. So what is family of parts? I'll tell you later. Right now, just have an idea. Family of part means, what can I say? Like for example, those parts which are pretty much similar to each other, but they differ in size. For example, you have this gears, cycle gears. Okay, cycle gears, like for example, it will be like this. In cycle, have you guys ever seen it? Especially if you have seen a gear cycle, you will understand. On this chain will be there, correct? On this chain will be there. Now, different sizes will be there. A big size gear, and then a small size gear relatively, and then even small size gear. You'll find it in gear cycles, correct? On this chain will be there. Now, this can be called as family of parts. This can be called as family of parts. So family of parts means it's like they are pretty much the same, but they differ in size, okay? Or there will be a little bit of difference between them. That we call it as what? Family of parts. The best example I gave you over here, cycle gears, okay? I hope you got it. Anyways, so if a group of machines has been put together to manufacture family of parts, then we call that as group technology, and that is nothing but cellular manufacturing, where you apply the group technology to increase the productivity. Are you able to understand? Right, anyways, so this is fine. Next. What are the benefits due to cellular manufacturing? This also we are aware of it. Your setup time gets reduced. The setup time is nothing but the time taken to get the machine ready for another production run. Now the question is, earlier, as per traditional manufacturing, we used to have very big machines where we used to spend 20 crores, 30 crores for all those machines, right? We call it as capital goods, capital missions, where we will invite tenders to come and build that particular mission in our factory premises, just like building a house. It was so complex. And because you were spending 20 crores, 30 crores on it, naturally what used to happen was the moment the mission has been built, your thought process was always on, I have spent 20 crores for this particular mission, so I have to ensure that this mission is fully utilized. So as a result, the performance measurement systems was based on mission utilization rate. You would have heard about it. There is something called mission utilization rate. The logic behind mission utilization rate being used as a performance measurement system is this one. Because I've spent so much of money and therefore I want to ensure that my machine is utilized fully, irrespective of the fact that whether that machine, if it is utilized fully, it will be manufacturing so many goods, so much of production will happen. Is there a real requirement of demand for all the production that is happening? Are you able to understand? So that fact is totally ignored, and blindly you're just trying to what? Utilize your machine fully to the extent of 100%, and based upon that, incentives used to be given, and that would lead to too much of stock getting piled up because there is no corresponding demand, and all these problems they used to face as per what? Traditional manufacturing. So therefore, once you have come to cellular manufacturing, now you are not using big machines, instead you are using smaller machines, and therefore obviously the setup time for smaller machines will be much lower. I hope you guys have understood this. And of course, coming on to material handling, so this is lean system and innovation. Obviously, smaller machines, so you handle less number of materials, therefore material handling cost gets reduced. WIP stock, obviously there is no question of WIP stock getting piled up, because in lean system and innovation chapter we have already seen, once you have applied the video tapes to reduce the setup time, what happened? The setup time has got reduced, and as a result, one mission time was very high, the other mission time was very low, and there was a lot of differences between the manufacturing times of different machines, which led to WIP inventory getting piled up in front of the slowest mission, correct? And to eradicate, because that WIP inventory getting piled up was creating so many problems, we were having you know, more defects were getting increased, and we had the problem of more working capital. Because of that, more opportunity cost, all these issues. So we found two solutions in our LSI chapter, that is Lean System and Innovation, to eradicate the WIP stock that gets piled up before the slowest of the mission, which is nothing but bottleneck mission. So that is, one is this one, cellular manufacturing. The second one is Kanban authorization. Although I will not be discussing Kanban authorization over here, but cellular manufacturing, we have seen it as a solution to avoid WIP stock getting piled up. So obviously, one of the benefits of cellular manufacturing is WIP stock getting reduced. Quite natural, quite obvious. Direct labor also gets reduced. Why? Because your idle time gets reduced. Earlier, there used to be big missions and you were not doing any sort of maintenance work, and frequently there used to be breakdowns, and when breakdowns are happening, the repairs and maintenance team, they will come and they'll try to check all these missions, and meanwhile what the direct labor will be doing? He'll be sitting quiet. There is a lot of idle time. Idle time means output will not happen, but still you have to pay. So that's why in standard costing also it's always adverse. Okay, so direct labor also gets reduced because the idle time gets reduced. Therefore, you are getting the best for the money that you're paying to the labor. Therefore, direct labor cost gets reduced because of cellular manufacturing. And of course, last but not least, reduced investment in plant and machinery. Why? Because you're buying smaller machines when compared to traditional manufacturing. And smaller machines are less costly, so the investment is less and they are easy to customize. Are you able to understand? So for example, in the class, those who have attended my face-to-face classes, we have done that jam bread example. We can easily convert that to, say for example, a cheese bread. It's easy for us, right? Why? Because the missions are pretty small, so it's easy to customize them according to your product requirements. But big missions, we can't do something like that. They are not that flexible the way small missions are flexible. You got the point? Anyways, now coming on to the second part of the question, he has asked you different types of mission cells. Okay, that grouping mission cells. There are actually 4 different types. First one is single mission cell. Second one is grouping mission cell with no automation whatsoever, which is nothing but with manual handling. Third one is semi-automation. Fourth one is full automation. It's very easy to remember. Single mission cell, group with zero automation, group with half automation, group with full automation. Very simple. So single mission cell means obviously it's useful for parts made by one single process. Okay, because there will be only one mission. Example, turning, milling, and all this kind of jobs. Group mission cell with zero automation means there will be no mechanical movement between two machines. One machine is there, another machine is there. Suppose here, if this machine has manufactured, it has finished its process, then automatically the output of this machine will not go to this particular machine as an input. This machine, okay. The labor has to manually involve and pick this from here and keep it over here. That we call it as manual handling. Okay. So this is nothing but group mission cell with manual handling. Okay. Next, group mission cell with semi-integrated handling. Here, what will happen? In few missions, from one mission to another mission, the parts will go automatically on a conveyor belt. I hope you guys have seen this conveyor belt in airports and all that, where we put the luggage and luggage goes automatically, right? So same way, if one mission finishes off its output, it goes on to the conveyor belt and then it just travels and get to another mission. So there's a bit of an automation. That's why it is called as group mission cell with semi-integrated handling. And finally, you've got flexible manufacturing system, which is nothing but fully automated missions. And that's how the manufacturing happens at Tesla. You can just, there are so many videos available regarding how manufacturing is happening in Tesla. You can just view it once so that you'll be understanding how this fully automated manufacturing grouping missions will happen. Okay. So that's it. We are done with answering all these things. Now only one thing is left over. That is nothing but rank order clustering algorithm. Okay. Now this is what I know you guys have been waiting for, but theory is also equally important. That's why I've covered theory as well. We cannot ignore theory. We cannot ignore theory. Okay. So, right. Let's solve this now. Rank order clustering algorithm. It's a very simple thing, Nana. It's not at all complicated, and it's purely based on, you can easily understand that. So it's a simple procedural aspect. Okay. Okay. Now to do this, first of all, this is applied over machine groups, machine part groups to be very precise, which means those machines which manufactures family of parts. I hope I have already told you what do you mean with family of parts. Okay. Chalo, having said that, now let's pick up the numbers from the question. Okay, so look at your question. We'll take the columns and rows. So we have columns for P101, P, P104, P105, P107, and P108. Those are all your columns. And let's go with rows for machines M2, M7, M13, M13A. Okay, just a second, guys. M2, M7, M13, M13A, M15. Okay, right. So we will rather put the boxes over here so that it will be easy for you to understand. Okay, next, this one. This one, yes. Okay. Right. So for that, it's a bit of a mess. Right. Right, guys. So now what we're gonna do is we're gonna call the columns as J and we're gonna refer rows as I. You can call it with any other name also, but your ICA has followed the same, so it's better that we follow the same so that our answer tallies with the key and eventually we get the marks and we pass the exams because that's our ultimate objective, right? Chala, so let's copy paste all the denotions from the question. So P101, it needs M2 as well as M13. P104, it needs M7 and M13A. P105, it needs only M13A. That's fine. P107, it needs M13. Sorry for that. It's M13 and M15. Right. P108, it needs only M7. Okay, that's it. This is your question. Okay, first what we are going to do is that we're going to assign binary weights. Just follow the procedure. You'll understand how simple it is. We're going to assign what, Nana? Binary weights. Okay. I'm writing J here because we're going to do it column wise now. Columns are represented by J. So therefore, we're going to do it column wise. And it's a pretty simple, binary weights. You know that binary means 2. So it starts with 2, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. Here we'll be trying to do the same, but with the help of a formula. So that is 2 to the power of, here I'll write, n minus j. N represents the number of components or types of components. J represents the column. So for example, if you just apply that formula over here for the first column, first we'll do column wise. Okay, you can start with row wise also, but we'll follow the procedure that IC has followed. Okay, so P101, 2 to the power of n minus j. So 2 to the power of number of components is 5 minus, what is this column? This column is first column, so 1. So this will be 2 to the power of 5 minus second column, 2 to the power of 5 minus 3, 2 to the power of 5 minus 4, 2 to the power of 5 minus 5. Okay. So that implies how much you'll be getting? 2 to the power of 4, 2 to the power of 3, 2, 1, and 0. You got it? So that implies you'll be getting how much? Let me change the ink color over here. So 2 to the power of 0 is 1. This will be 2. This will be 4. Okay. 2 to the power of this will be 8. And this will be 16. So this is not going to change. Are you able to understand? You got this? So in fact, you can do this directly also. So binary weights means obviously you will start with on the right side always, or if it is row wise, you will start from the below, and then you will be writing 2 to the power of 0, then 1, 2, 3, 4, 5, and so on. So it's very easy, but still we have followed the formula that has been given by your ICA, so that we match with the answer as it is. Directly we can also write 2 to the power of 0 from the right hand side, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. Why 2? Because it's binary weights. Bi means 2, right? So obviously that's the logic. Anyways, so we got the 16, 8, 4, 2, 1. That number is very important for us. And now we're gonna go with decimal equivalent. So what do you mean by this decimal equivalent? This we're gonna do for row wise. Row wise means I'll write I here. I'm gonna do it row wise. Therefore, I'm gonna write I because I represents rows in this particular question. Okay. Now, how am I going to write decimal equivalents for each of the rows over here? Very simple. If you look at P101, you got M2 and M13, right? Okay, now I'm going to do it anyway for row wise. So in this particular row, M2, you have only P101, which represents how much is the number over here? 16. So therefore, what I'm going to write? I'm going to write 16 over here. Are you able to get me? So why? Because P101, in this entire row, there is only one, which represents M2. Okay, P101 needs machine 2. And as you can see in this particular column, the binary weight that we have given is 16. Therefore, 16 will come here. Now, what about the second one? Now, second one you see, you'll understand better. This one plus this one. This one plus this one, correct? This one, how much is the number? 8. This one, how much is the number? 1. So 8 plus 1. So which means now the number is going to be how much? 9. You got the point? Decimal equivalent. Next. Now next one, now you'll understand even better. This one plus this one, third row. So this one represents 16 binary weight and this one represents 2 binary weight. So 16 plus 2 will give you this particular row, which comes around 18. You got this? Next, this one and this one. So 8 and 4. You got it, guys? 8 and 4. So which means that will be 12. And then the last one, obviously. So coming on to last one, it's gonna be only this one, which is 2. So therefore, last row, it's gonna be 2 for that matter. Okay. Now, once you are done with this decimal equivalent, immediately what you have to do is that you got to give the ranking. So let's give the ranking. I'll change the ink color over here. So who's gonna be your first rank? Whichever decimal equivalent is highest, that will be your first rank. So obviously your first rank will be 18, second rank will be 16, third rank will be 12, fourth rank will be 9, and fifth rank will be 2. Pretty simple, right? You got this? Okay. So once we are done with this, what we have to do is that now again we have to rewrite the rows, because right now all these things has been happened for rows, right? We need to rewrite the rows or shuffle rows based on the ranking. We need to rewrite the rows or shuffle rows based on ranking. So which means the first row will be M13 machine, second row will be M2, third row will be M13A, fourth row will be M7, and fifth row will be M15. So that's how we're gonna write our next one, next matrix. Okay, chalo. So let's go for second matrix over here. M13, M2, then M13A, then M7, then M15. Okay, so I'm gonna go in the same way. Right, see here, guys. M13, M2, M13A, M7, M15. Okay. Here the columns will never change. Okay, columns will remain the same, which means P101 to 108. So P101, P104, P105, P107, P108. So again, we're gonna have another box. To be precise, another matrix. Right. I hope this is enough from here after. Okay. Shala. So this will be I and this will be J. Rows will be represented by I and columns will be represented by J. Right, guys. Okay, now what we have to do? Now, last time we gave, let me put a line over here so that it will clearly demarcate. Okay, I'll go with the dotted line. Okay, it will clearly demarcate that as the previous step. So that should be fine. Right, guys. So last time what we have done is that we went with column wise. Okay, we went column wise. We started with the first column P101, then we went to the last column P108. That's how we have given binary weights. Now we're gonna give binary weights for row wise. So which means we're gonna start here. Because it is row wise, I'm gonna write it as I. Here we have written J because binary weights was done column wise, so it is J, and decimal equivalent was done row wise, so it is I. Now I'm gonna do binary weights, row wise, so it is I, and decimal equivalents obviously we'll be doing column wise, so it's gonna be J. Because last time we have already done column wise, now we're gonna do it row wise. That's the only logic. Apart from that, nothing else is there. We'll keep on repeating this till one particular point. What is that? I'll tell you later. Right now, let's go with the binary weights. Before we get to that, first let's fill up this particular table. M13P101. So look at your question. M13P101. So it will be here M13. M13 needs P101 and then P107. So I'll write this way. Write this way, it will be very easy. First of all, see M30 machine manufactures what parts? So P101, P107. They enter the matter. M13 is gone. Then M2. What are the parts it is manufacturing? P101 only. Okay. Then M13A, what are all the parts it is manufacturing? P104, P105. Look at your question. Look at your question. Look at your question. M13A manufactures P104 and P105. So P104 and P105. Next, M7. M7 manufactures P104. M7 manufactures P104. Then M15. M15 manufactures P107. M15 manufactures P107. You got it? M7 manufactures 108 also. So I'll put that over here. Right, guys, that's it. So I've put all the numbers from the question. Okay, now let's go with binary weights over here. Again, same logic. You start from the last. You can start with 2 to the power of 0 directly, or you can use the same formula. 2 to the power of 5 minus, this is your last row. First row, it will be 2 to the power of 5 minus 1, then 2 to the power of 5 minus 5 minus 2, 2 to the power of 5 minus 3, and 2 to the power of 5 minus 4. So this time we'll directly put the numbers. 2 to the power of 5 minus 5 is 2 to the power of 0, which will be 1. This is 2 to the power of 1, which will be 2. This is 2 to the power of 2, which will be 4. This will be 8, and this will be 16. You got this? I have put the numbers directly. Now, once we are done with this, then we will do decimal equivalent. Now we're gonna do it column wise. Okay. So decimal equivalent column wise. So therefore, it is J. Very simple. Now you people tell me column wise. This is the first column. This is the first column. Okay. First column means how much is the number? This is 1, which represents 16 binary weight, and this represents 8 binary weight. So for this total column, it will be 16 plus 8. So that will be how much? 24. That's your binary weight. Coming on to the second column, 4 plus 2. So that will be 6. Third column, 4. Okay, 4. Fourth column, 16 plus 1. 16 plus 1. Fourth column, 17. Last column, only this one, which is 2. Okay, now we have given, we are done with decimal equivalents for all the columns. Obviously, we'll go for ranking. So let's give the rank. Who's gonna be your first ranker? 24, 17, 6, 4, 5. You got this. So 1, 3, 4, 2, 5. That will be your ranking. Now what we have to do, we got to shuffle based on the ranking. Which one? Columns. Now we're gonna shuffle the columns. So which means first we're gonna write P101, second P107, third P104, fourth column will be P105, and fifth column will be P108. Right, chalo. Let's write the columns, Nana, then. So first one will be P101, rank 1, rank 2 P107, P104, P105, P107, P104, P105, and obviously P108. That's the last one. Okay, we have written the columns based on the ranks. Now rows will remain same. Will remain same means this one, this particular order. M13, M2, M13A, M13, M2, M13A, M7, M15. Okay, I hope this is clear. Okay, so we got our rows and columns I and J. We can write this as well. Right, that's enough. Chalo, now what we're gonna do? We're gonna again assign binary weights. Okay. Last time we have given binary weights to rows. Now we're gonna again give binary weights to columns. So till what time we're gonna do? We're gonna keep on doing it. I will tell you when to stop, and I'll tell you the reason when it comes. Till that time, we're gonna repeat the same stuff. So right before we get to that, let's fill up these numbers over here. So first we'll start with P101, M13, M2, M13, M2. Okay, P101. Then P107, P107. Here you see M13, M15, M13 and M15, M13, M15. P104, P104, M13, M7. So M13 and M7, M13, M7. P105. So P105 is this one, M13A, only one. P105, M13A. Okay, P108, only one again, M7. That's part 108, M7. That comes around here. You got this? P104, M13A, right? Sorry. P104, M13A. I hope this is clear. Right? Chalo. Now. So now let's go with binary weights. Okay. Chalo guys, let's do this. Again, we can start with the last column. So 2 to the power of 0, 2 to the power of 1, 2, 3, 4. Directly I've put the numbers now. So this will be 1, 2, 4, 8, 16. Again and again, we have to repeat the same thing. Okay, so there's nothing different. Right, now we're gonna go with decimal equivalent for rows. Therefore, I'm gonna write I. And you people tell me now, very easy. So these two for the first row. This one is 16, this one is 8. 16 plus 8, it's gonna be 24. Second row, okay, only 16. Okay, third row, this one plus this one. So 4, this one 2, 4 plus 2, 6. Fourth row, this plus this. So this one is 4, this one is 1. So it's gonna be 5. Fifth row, only 1, and that represents 8. 8. So 24, 16, 6, 5, and 8. So now we're gonna give the ranking. Obviously, first rank will be 24, second, third, third one is 8, fourth, fifth. अरे यार highest, right? Chalo. So 1, 2, 4, 5, 3. That will be your ranking. Now again, based on this ranking, again we need to shuffle the rows. Okay, so let's shuffle the rows again. Okay. Shuffle the rows means the first row will be M13, second will be M2, third will be M15, fourth will be M13A, fifth will be M7. Okay. So let's shuffle the rows then. M13, M2, M15, M13A, M7. Rank 1, M13. Rank 2, M2. Rank 3, M15. Rank 4, M13A. Rank 5, M7. Okay, columns will remain the same. Will remain the same means this previous step you need to write as it is. So P101, 107, 104. P101, 107, 104. P105, 108. Okay, again the same stuff. Right, guys. Right, row, column, and we'll just write the columns. Right. Okay, first let's write the numbers over here. I mean the denotions. Okay, we'll start with M13. So M13, P101, 107. Okay, next M2, P101. M15, M15 is P107. M15 is P107. Right. M13A, M13A, P104, 105. M13A, P104, 105. So 104 and 105. M7, P104, 108. P104 and P108. Okay. Right, done. Okay, now what we're gonna do? Last time we gave binary weights to columns. Now we'll give binary weights to rows again. So binary weights to rows. So that is I. Okay. So obviously we're gonna start with the last column. So that will be 2 to the power of 0, 2 to the power of 1. Sorry, last row. 2 to the power of 1, 2 power 2, 2 power 3, 2 power 4. Okay, so that implies 1, 2, 4, 8, and 16. Okay, so that's it. Our binary weights are done. Now let's go with decimal equivalents for columns. So that is J. Okay, so now you people tell me very easily. So these two. So what will happen for this entire row? How much will be the value? Okay, now we're gonna go with the columns now, right? This one and this one. So this one is 16, this one is 8. So that will be 24. This one is 16. Okay, this one is 4. This one is 4, this one is 16. So that will be 20. Next, third column. This one is 2, this one is 1. 2, 1, 2, 1. So that will be 3. Right? Next, this one. Only 2. This one, only 2, only 2. Fourth column. And last column, this one, only 1. So if you look at the ranking, 1, 2, 3, 4, 5. You got this? So when you have got this ranking which is neatly arranged in order, this is where you have to stop. Are you able to understand? So why is that we have to stop here? Because your ranks are in order. So what is the use of it? You will understand. Now see here. What is the use of it means? See what's happening. If you can see this entire table over here, you can find two clusters. I'll show you what are those two clusters. Alright. This is one cluster. This is another cluster. Can you see that? Cluster of machines. For this only, we have done so much of hard work so far. What do you mean by cluster of machines? Means what? Part 101 and part 107 needs machine 13, machine 2 and machine 15. They do not need machine 13A and machine 7. So this will be one cluster. This will be one cluster. And machine 13 needs part 1. I mean machine 13 manufactures P101 and P107. It doesn't manufacture 104, 105 and 108. Are you able to understand? Similarly, part 104 and part 105 and part 108 needs only machine 13A and machine 7. They do not need machine 13, machine 2 and machine 15. Therefore, you have divided them into two clusters clearly. This is what we call rank order clustering algorithm, because we have clustered the entire machines into two equal parts. Part 101, 107 with machines 13, 12 and 15. Part 104, 105 and 108 with machines 13A and machine 7. Are you able to understand? You got this? So this is the hard work. This is the reason why we have done so far. Okay, now, so your final answer will be, so part families and machine groups. Part families and machine groups. How are we going to create this? So two clusters. Clusters, or you can also call it as machine cells. Okay, what are all the parts getting manufactured over here? What are all the machines that are present in those clusters? Okay, chalo. So cluster number 1, we get part 101 and part 107. 101, part 107. What are all the machines we have? 13 to 15. So this is one cluster. Cluster 2, generally clusters are represented in Roman numbers. Cluster 2, part 104, 105, 108. Part 104, 105, 108. And coming on to the machines 13A and 7. You got it? That's it. This is your answer. For this only we have done all this hard work so far. You got the point? So now we have divided them into two clusters. So now what will happen because of this? There will be optimal manufacturing, there will be lesser movement of parts, and there will be increase in productivity and all those things as expected by Mr. Mishra. And that's the way it works. You got the point? This is what we call rank order clustering algorithm. Okay. I hope this has been made really easy for you. There is one more problem as well based on this. In that problem, there will be one new point that we need to learn. Apart from that, everything is pretty much the same. So it is. So I hope this has been made easy for you because of this particular video. Okay, guys. So thank you so much. With this, we'll wind up this particular session. Thank you, guys.